We now choose the equation that corresponds to this given slope field. So for this, I'm going to use the information between the slope marks and corresponding slope. So whenever the slope mark looks like a sort of a horizontal line, the slope is zero. And whenever it looks like a sort of increasing function, we say that the slope is positive. And whenever the slope mark looks like a sort of decreasing function, we say that the slope mark is negative. And whenever it looks like a vertical line, we say that the slope is undefined. So we will utilize this information to determine the equation that corresponds to this slope field. So first, I'm going to look for slope marks, which looks like a horizontal line, and this means the slope is zero. And if we observe this slope field at y equal to zero, we have this horizontal lines. So this we can say that the slope field at y equal to zero is zero, and similarly at y equals -2, we have this sort of slope marks. That is, they all look like horizontal lines. So which means the slope is zero at y equals -2 as well. Next, we look out for this slope mark, which looks like a sort of increasing function. Clearly, at y equals -1, we have this slope marks. That is, they look like sort of increasing. So that means the slope is positive at y equal to -1, as plus when you look at y equal to 1, they look like sort of decreasing. So we say that at y equal to 1, the slope is negative. So now we are going to utilize this information and match the corresponding equation. So first, let's look out for the slope is 0. We understand that the slope is 0 at whenever the y equals 0 as plus whenever y equals -2. Now, looking at this option, all these options has a product of y with another expression, which means they all become 0. Uh, they all become 0. So we then have to look out for the other option, that is whenever y equal to -2, the slope has to be 0. Only this part, that is the equation given in part A and part B, is 0. That is, the slope is 0 whenever y is -2. Because in part A we have the equation y prime equals y times of y plus 2, and when we replace y by -2, we get -2 times of -2 plus 2. This becomes negative times of 0. So this is 0. And similarly in part B, we have the equation y prime equals -y minus 2 times of y. And when we replace y by -2, we get negative y will become positive 2, and this becomes 2 minus 2 times of -2. So basically this is also 0. So only in part A and part B the equation satisfied when y equal to -2. However, in part C we have y minus 2 times of y. So if you replace y by -2, this becomes -2 times of -2, which is a -4 quantity. So it is not becoming 0 at y equals -2. As well as the equation given in part D, this also does not become 0. So we can ignore these two equations. Now let's focus only these two equations, that is equation A and B. Now let's utilize the another condition, that is at y equal to -1, the slope should be positive. So let's consider the equation in part A. We have y prime equals y times of y plus 2. So now I'm going to substitute y equal to -1. So if I replace y equal to -1 into this equation, I get a -1 plus 2. This becomes a negative of, that is -1 times of -1 plus 2 is positive 1. So basically this gives a negative. But we know that at y equal to -1, the slope is positive. So this means clearly the equation in part A, we can ignore that, and therefore it should be the equation given in part B. However, we will verify that. So let's use the part B equation. We have y prime equals -y minus 2 times of y. So I'm going to substitute y equal to -1 into this equation and see if I'm getting the positive slope. So let me do that. So when I replace y by -1, this negative y will become positive, and this becomes 1 minus 2. And here we replace y by -1, so this becomes -1. So 1 minus 2 is -1. -1 times of -1 is positive. So clearly this equation satisfies the condition. So therefore we see that the equation given in part B, that is y prime equals negative y times of negative y minus 2 times of y, is the equation that corresponds to the given slope field.